In this video, we're going to learn how to find derivatives using the product rule. The product rule can be used to find the derivative of a product of functions. So the rule says that the derivative of f of x times g of x is equal to the derivative of f times g plus f times the derivative of g. And because of the commutative property of addition, sometimes we could see this written differently, and the same thing for the commutative property of multiplication. Here's the way I look at it though. I think about the original functions are in the inside and they're flip-flopped. And then these are our derivative functions. So you may see the product rule written differently in other places, but they are all equivalent. This will be the most similar to the quotient rule, which you'll learn about in another video. Take note here, if the two functions are polynomial functions, you could also multiply them and then find the derivative using power rule. All right, for A, it says find the derivative using multiplication and then the power rule. Well, we can multiply these two binomials. Okay, you could think about it as distributing or FOIL if you've learned that before. So I have 2x squared minus 6x plus x minus 3. I can combine like terms in the middle, so 2x squared minus 5x minus 3. And when I take the derivative of that using the power rule, I'm going to get 4x minus 5. Now for part B, we have the same exact function, but we're going to use the product rule, and we're going to make sure that it gives us an equivalent answer to 4x minus 5. So if I want to find the derivative here, the way I'm going to set it up is if you look at the formula for product rule, there's really 4 components to it. If you notice, I'm highlighting in 4 different colors here. So I'm going to set up 4 parentheses, 2 and then a plus sign, and then 2 more. So the first is derivative of the first term. So the derivative of 2x plus 1 is 2 times the second term plus the first term times the derivative of the second. Okay. I know there's an f of x here. If it helps you to put these as like f and g, you can, or you could always just think about it as the first function and the second function. All right, let's simplify this here. So I have 2 times x minus 3, so that's 2x minus 6. 1 times 2x plus 1 is just 2x plus 1. And if I simplify this here, I get 4x minus 5 as my derivative, and we can see that that matches. So if that's the case and you just have polynomial functions that you can multiply, power rule still works. But you'll see on a lot of the questions in this video that we are basically forced into using the product rule. All right, let's take a look at some examples. So number 1, we have f of x equals 2x times sine x. You want to make sure you see what the two functions are. So 2x is one, sine of x is the other. I'm going to, just like before, I'm going to set up my parentheses with the plus sign between 2 and 2. And now I'm going to substitute. First parentheses is the derivative of the first term times the second term plus the first term times the derivative of the second. And then I'm just going to rewrite it and clean this up without all these parentheses. Now, sometimes you'll see that there are questions where we can do a lot of simplification. This isn't one of them. I'm just going to leave it like this. I suppose if you really wanted, you could factor out a 2, but I don't personally feel that is necessary in this problem, but it is equivalent. Okay, in case you were looking at a multiple choice question somewhere, note that this is a possibility. All right, number 2. G of x equals x cubed times e to the x. So here's our first function, here's our second. I am going to set up my 4 parentheses. And in my first parentheses is going to go 3x squared times the second plus the first times the derivative of the second. And we are just going to clean this up. Note, by the way, that e to the x, the derivative of it, is itself, so that's why that appears twice in the equation there. All right, so this is going to be 3x squared e to the x plus x cubed e to the x. Again, could you factor out a GCF here? Sure, I suppose we could. We could say that x squared e to the x is a GCF, and then we're left with 3 plus x, but both are equivalent. All right, let's look at some more. Number 3, since I see that they're both polynomials here, you have an option of whether you want to use product rule or you want to multiply them and use power rule. I'm going to stick with product rule for the sake of this video, but just know, just like we showed before with questions A and B, you will get an equivalent answer either way. Okay, so setting up my parentheses. All right, now since I have all polynomial terms here, I am going to simplify this and multiply and distribute where I can. So over here, I have 2x plus 2 times x minus 2. I can distribute those binomials against one another, or I could think about it as FOIL. Over here, I'm multiplying this by itself, by 1, so I'm just going to get back itself. And then I'm going to see, can I combine any like terms? So I have negative 4x, 2x, and 2x I can see, 2x squared and x squared, and then I have negative 4 and 3. Okay, so those are my like terms, so let's combine where we can. So 3x squared, the x terms are going to go away because those equal 0, minus 1, and we have our answer. Number 4, we have, we're taking the derivative of 5x to the 4th minus 6 times the ln of x. All right, derivative of the first using power rule is 20x cubed. Remember, the derivative of negative 6 is 0 times ln of x plus 5x to the 4th minus 6 times 1 over x. Okay, and I'm going to clean this up without the parentheses here. And over here, I'm going to merge this into a single fraction. Could we do other things here to simplify? Of course, we could get common denominators if we wanted. I'm just going to leave it like this, though. All right, number 5 is a very interesting question because we have x times radical x, and that's equivalent to x times x to the 1/2, right? The square root of x is the same thing as raising x to the 1/2 power. So I could actually multiply this. This would give me x to the 3/2. I would add those exponents together because remember, this is like x to the first here. And then I could really quickly use power rule. If I did that, I would get 3/2 x to the 1/2 or 3 radical x over 2. Let's say I didn't see that though, and I go ahead and I do product rule. Okay, nothing wrong with that. Derivative of the first term times the second plus the first term times the derivative of the second. So I get radical x plus x over 2 radical x. And you might say to yourself here, well, those answers definitely don't look equivalent. No, they don't, but if I did simplify it, I would get the same answer. So I'll just show you here. If I put this over 1 and I got common denominators, so I multiplied by 2 radical x on top and bottom. Radical x times radical x is x. This is an x down here, by the way. So that would give me 2x plus x over 2 radical x in the denominator. This would be 3x over 2 radical x. And then if I simplify this here and I think about rationalizing the denominator, I can multiply top and bottom by radical x. And I'm going to get 3x to the 3/2 over 2x. Again, we're getting closer. It's not completely matching yet, but since these are both the same term, raised to different exponents, we subtract the exponents. So I get 3x to the 1/2 over 2, or 3 radical x over 2. And now we can see the equivalent answer. Number 6, derivative of your first term times the second plus the first term times the derivative of the second. And I could rewrite this as cosine x squared minus sine of x squared, or sine squared x is the correct way to write that. And I'm going to leave my answer just like that. You're going to see in a lot of the questions, there's simplifying you could do or not do. Think about the previous question, all that simplifying we did just to show those answers are equivalent. But just keep in mind there are different ways you could format your final answer. Okay. For the remainder of the questions, I am going to not simplify them. I'm just going to plug into the product rule and stop there. All right, for 7, derivative of the first times the second plus the first times the derivative of the second. And like I said, I'm going to just leave it like this rather than overcomplicate and oversimplify. Number 8. The derivative of cosecant is negative cosecant x cotangent x times the second term, negative 2x cubed, plus the first term, cosecant x, times the derivative of the second, which is negative 6x squared. And again, I'm going to leave it like this. We could simplify and write without a common denominator. Actually, on this one, you know what? I'm going to do one quick thing and just multiply these negatives together and format it a little bit nicer. But I'm not going to take any greatest common factor out. There is one, but I'm going to leave it like this otherwise. Number 9, the derivative of 2 to the x times secant x. Okay, derivative of the first is 2 to the x ln of 2 times the second term, secant x, plus the first term, 2 to the x, times the derivative of the second, which is secant x tangent x. And all I'm going to do to clean this one up is just rewrite it without the parentheses so it doesn't look so cluttered. But of course, they're equivalent either way. All right, our last problem, number 10. We're taking the derivative of negative sine x times the cube root of x. And I just want to take note that that's equivalent to negative sine x times x to the 1/3 power. All right, the derivative of the first, the derivative of negative sine is negative cosine times the second term plus the first term. You could just write that as a minus instead of plus and negative if you prefer, times the derivative of the second. So 1/3 x to the negative 2/3. One thing I am going to do to clean this question up is two things, actually. I am going to just rewrite this as negative cube root of x cosine x, putting the trig function at the back. Over here, I have plus a negative, so I'm going to change that to a minus. And I'm also going to rewrite this negative exponent so that it's positive and it has a square root or radical symbol in this case. That's because the problem has a radical, so I'm going to try and mirror that format. So this would give me sine of x over 3 times the cube root of x squared, and that would be my derivative for number 10.